Alright, hey everyone, we've looked at the shapes of galaxies by looking at deep space objects in the planetarium, but now what we want to do is talk about those shapes and how they possibly change over time. What are we seeing here?
Well, it's kind of hard to tell. It's like a clump of stars together, but there's definitely a shape to it. You can see that it's flat if you look at it edge on, and as you turn it, it's kind of pinwheel-like.
It's got some spiral arms here, so this will be more of a spiral galaxy.
This one here is slightly different. It doesn't have that flat thing. It's more circular, maybe oblong, egg-shaped, like an ellipse.
There you go. So this is more of the elliptical type galaxy. There is no distinct disk like we saw with spiral galaxies. So when we look at these different shapes out there, the question is, how could galaxies change? How would they evolve over time, and do they evolve into different shapes? And one way they can change is by galaxies being close to each other.
Yeah, it turns out that gravity can overcome expansion of the universe and bring two galaxies together. And if you do that, they certainly change shape.
All the hundreds of billions of stars in the Milky Way and all the hundreds of billions of stars in the Andromeda galaxy, their mutual gravity can pull the entire masses together. So we can see and watch two galaxies merge over time, and as these galaxies merge, their galactic centers are going to merge, their spiral arms are going to merge. And remember that every dot of light that you're seeing in this simulation here is the sun.
And I can already see gravity manipulating the shape of one of the two galaxies. I think the shape will change significantly. Now what we're seeing here is not an explosion. It's not like these things hit together and suddenly blow up. There isn't any real damage done. It's just things are being moved around by the gravitation.
And the space between stars in a galaxy is so large that actually there's no collisions between stars most of the time. So now that when galaxies do merge and galaxies come together, we now see a completely different shape. Like, I don't really see the spiral disk shapes I saw before. I might call this an irregular galaxy based on the odd shape that this has made. And you can see all the stars and clumps of stars being kind of pushed away. Now maybe there's some distinct spiraling happening.
We'll let another billion years go by and who knows what shape we'll get.
So galaxy evolution is a complicated process. We're going to go over two options of the way that scientists think galaxies can change and evolve over time. So we see this collision and these mergers happen a lot in the universe, that galaxies that are close to each other.
Yeah, in about 3 billion years, so I wouldn't wait up.
Andromeda and the Milky Way are on a crash course. They are going to merge one day and then possibly change into a different shape. So let's talk about the ways they can change.
Well, the classic way that we've always learned, or at least the way that I've been taught that galaxies change, is that they start out as ellipticals and gradually move towards spiral galaxies. What happens is rotation and gravity cause the arms to form as time goes on. Some different shapes can occur, but basically you end up with a spiral galaxy.
So the elliptical starts off as like a ball of stars, and as gravity pulls them together, they start to collapse and spin, they flatten out, and the spiral arms stretch out from there.
Right.
So when we see elliptical galaxies, we could be seeing younger galaxies, and when we get to the spiral galaxies, we see more older galaxies.
Right. In recent months, it's come to my attention that it might be working in the opposite direction.
So that when we see galaxies collapse and pull together, they seem to start that spiral shape maybe right off the bat. And if they start that spiral shape right off the bat by merging with other galaxies, well, in the arms, we're going to see a lot of younger, brighter stars.
Now, as those stars gradually die, they become invisible. You no longer have the arms, and you just basically have what were the younger stars are now becoming older stars, and they become an elliptical shape because that's all that's left of the galaxy.
So the ellipse, or the central bulge in the middle of those galaxies, is what's left behind, and we no longer have that spiral shape. So there's two ways that you could go across this diagram. You could go from the left to the right, having ellipses collapse into spirals and give you the arms, or galaxies could start with their spiral shape to begin with. As all the gas and dust and stars pull together, eventually, like you said, the young stars use up all the gas and dust, and when all the spiral arms are used up, you're left with an ellipse.
Yep.
And we do measure a lot of old stars in elliptical galaxies. We don't see a lot of rotation with them, so that's another piece of evidence that this whole thing could work in reverse.
Even though we've been looking at galaxies from a great distance, you can still back out further, and the further and further you get away from galactic centers and then seeing the entire galaxy and then seeing local groups of galaxies, if you back out far enough, you'll notice that the galaxies are grouped in really large clusters. Like here, we can see that they're grouped in a cluster together because of gravity. And if you zoom further out, you find superclusters of galaxies as well.
So superclusters being these very large concentrations of galaxies right here in the middle of this image. But you also find that there are spots in our universe where there really is nothing. There's an absence of galaxies.
Yeah, those are the holes you look through to find the cosmic background radiation.
There you go.
In conclusion, time can not only create galaxies, but it can change galaxies over time. And there are a couple different ways that can happen. There are also different ways that they can form in the first place. So when you're considering galaxies, consider that there are many different types and many different ways that those types can occur.
Sounds good. We'll talk more specifically about our own home next time.
Yep.